We have triangle ABC here, which looks like a right triangle. And we know it's a right triangle because 3 squared plus 4 squared is equal to 5 squared. And they want us to figure out what cosine of 2 times angle ABC is. So that's this angle, ABC. Well, we can't immediately evaluate that, but we do know what the cosine of angle ABC is. We know that the cosine of angle ABC, well, cosine is just adjacent over hypotenuse, is going to be equal to 3/5. And similarly, we know what the sine of angle ABC is. That's opposite over hypotenuse. That is 4/5. So if we could break this down into just cosines of ABC and sines of ABC, then we'll be able to evaluate it. And lucky for us, we have a trig identity at our disposal that does exactly that. We know that the cosine of 2 times an angle is equal to cosine of that angle squared minus sine of that angle squared. And we've proved this in other videos, but this becomes very helpful for us here because now we know that the cosine, let me do this in a different color. Now we know that the cosine of angle ABC is going to be equal to, the cosine of 2 times the angle ABC, that's what we care about. 2 times the angle ABC is going to be equal to the cosine of angle ABC squared minus sine of the angle ABC squared. ABC squared. And we know what these things are. This thing right over here, is just going to be equal to 3/5 squared. Cosine of angle ABC is 3/5, so we're going to square it. And this right over here is just 4/5 squared. So it's minus 4/5 squared. And so this simplifies to 9 over 25 minus 16 over 25, which is equal to 7 over 25. So this thing right over here is equal to 7. Sorry, it's negative. Got to be careful there. 16 is larger than 9. Negative 7 over 25. Now, one thing that might jump at you is why did I get a negative value here when I doubled the angle here? Because the cosine was clearly a positive number. And there you just have to think of the unit circle, which we already know is an extension. The unit circle definition of trig functions, which is an extension of the SOHCAHTOA definition. X-axis, y-axis. Let me draw a unit circle here. My best attempt. So that's our unit circle. So this angle right over here looks like something like this. So it looks like something like this. And so you see its x-coordinate, which is the cosine of that angle, looks positive. But then if you were to double this angle, it would take you out someplace like this. It would take you out someplace like this. And then you see by the unit circle definition, the x-coordinate is now, we are now sitting in the second quadrant, and the x-coordinate can be negative. And that's essentially what happened in this problem.